Hello friends, welcome to my channel Patra tutorial. In this video I will be discussing resource allocation graph. Okay, so we are discussing deadlock in operating system, and in this video I will be discussing resource allocation graph. Okay, so what is resource allocation graph? So a deadlock can be described more precisely in terms of a directed graph. Okay, a directed graph called resource allocation graph. Okay, so as I already told in the previous video, if there is a circle in resource allocation graph, then we can tell something about that system. Okay, whether it is in deadlock state or not, or what is the possibility of deadlock, all these things. Okay, so the set of vertices B and set of edges E. So resource allocation graph, or RAG, consists of a set of vertices and edges. Okay, so a resource allocation graph consists of a set of vertices V and set of edges E, and each vertices, or there are two types of vertices are there in resource allocation graph. So first one represent process. Okay, that is process, and second one represent resources. Okay, resources. So RAG, or resource allocation graph, is a set of vertices and edges, and there are two types of vertices are there. First one is P, set of processes, and second one is R, set of resources. Okay, and as I said earlier, each resource may have more than one instances. Okay, so that I will discuss in the later on. Okay, so each vertices, or the vertices are of two types. First one is process and second one is resource. Okay, the set consists of all the resource type in system. Okay, and this P is the set consisting of all the processes in the system. Okay, next is there are two different types of edges are there. First one is request edge and second one is assignment edge. Okay, see, directed edge, both the edges are directed edge, but if the edge is request edge, then it must be going from process to resource. Okay, and if it is assignment edge, the directed edge must be coming from resource to the process. Okay, so this direction of this arrow will represent whether it is request edge or assignment edge. If the arrow is towards resource, then it is request edge, and if the arrow is towards process, then it is what? Assignment edge. Okay, that means what? This resource is already being assigned to this process, and this means what? This process Pi is requesting the resource Rj. Okay, so the resource allocation graph, okay, consists of what? Set of vertices B and set of edges E, and again the vertices are of two types. First one is P and second one is what? R. So P represents set of processes and R represents set of resources. Okay, and each resources can have more than one instances. Okay, instances. Okay, so we'll discuss, we'll see one example of this resource allocation graph. So let us have a look at this resource allocation graph. Okay, so as I said earlier, it is consisting of two types of vertices, this round shape and this rectangle. Okay, so this round shape vertices represent the process and the rectangle represent the resource. Okay, so now see, the R1 is a resource, and R1 consisting of only one instance, right? R1 consisting of only one instance. Okay, then R2 is having how many instance? Two instance, this one and this one, right? So R2 is a resource and it is having two instances. Okay, now R3 is having only one instance, this one, and R4 is having three instances. Okay, this one, and this one. Okay, so in our resource allocation graph, four resources are there: R1, R2, R3, R4, and they are having different numbers of instances. Okay, so some are having only one instance and some are having more than one instances. Okay, now T1 represent one process. Okay, this circle represent process. Okay, so T1 is requesting for R1. See, this is requesting a request edge, right? And this is assignment edge. So T1 is requesting for R1 and holding R2. T1 is holding an instance of resource type R2 and requesting for R1. Okay, and T2 is holding two instances, right? This one and this one. Okay, so T1 is holding two instances. One is of type R1 and another is of type R2 and requesting for R3. Okay, so T2 is one process which is holding two resources. One is of type R1 and one is of type R2 and it is requesting for R3. Okay, and T3 is another process which is holding one instance of resource R3. Okay, so these arrow marks are very important. See, this is one assignment edge, right? And this is coming from this instance, not from this circle or this rectangle. Okay, so the assignment must be from an instance and request edge will go up to this rectangle, not inside the rectangle. Okay, but if it is assignment edge, then it should point or it should indicate clearly to an instance. Okay, so these two are both are in assignment, not assignment, these are what assignment edge, right? So this arrow is carrying this instance and this arrow is carrying this instance. Okay, but this is request edge, so it will just request for the resource, not for instance. Okay, okay, next T3 is holding one instance of R3, right? So this is one resource allocation graph. Now see, this is one circle, right? T1 is waiting for R1 which is held by T2. No, there is no circle, there is no circle, so we can't comment anything here. Just this is the example of one resource allocation graph. So it is consisting of set of vertices, this one T and R, and set of edges. Now let us look at some example. Okay, so this is one example. Now see, T1 is holding one resource of type R2 and it is requesting for R1. Okay, and T2 is holding one instance of type R1 and one instance of type R2 and it is requesting for R3, right? And R3 T3 is holding one instance of type R3 and requesting for R2, and R4 is having three instances but it is not being assigned to anyone. Okay, this is no use. So now see, look at this graph. This graph is having one circle T1 is holding R2 requesting for R1, T2 is holding R1 and requesting for R3, and T3 is holding R3 and requesting for R2. So this is one circle, right? This means this is satisfying hold and wait condition, this one, right? So see, first one is what? Mutual exclusion, right? Mutual exclusion is satisfying. And second one is what? Hold and wait. So each process is holding something and requesting for something. Okay, then now preemption. So since this resource allocation graph is having one circle or circle, then means yeah, we can say circle of waiting processes. Okay, then we can say this is in deadlock state, because see, T1 will not release until it is not getting R1, and T2 will not release R1 until it is getting R3, and T3 will not release R3 until it is getting R2, and T1 will not release R2 until it is getting R1. So both are means all the processes are holding something and waiting for something, and the instance they are requesting is already being held by some other process, so they will be keep waiting for ever. So this is in deadlock state. So this is one cycle is there and the system is in deadlock state. Okay, and let me give one more example here. So this is one more resource allocation graph, and in this graph there are four processes are there. This is T1, T2, T3 and T4. Okay, and there are two resources are there. One is of type R1 and another is of type R2. Okay, and R1 is having two instances, R2 is having also two instances only. Okay, now see, is there any cycle here in this graph? Yes, it is there. T1, R1, T3, R2, then T1, right? So cycle is there in this graph also. Okay, like this. Okay, but is it in deadlock state? Now see, T1 is holding one instance of type R2 and requesting for R1, and T2 is holding one instance of type R1 and requesting for R2. Okay, so this is this looks like this is in deadlock state, right? This part. Okay, but see, R1 is having two instances, right? This one also there, and this is currently being held by T2. Okay, and T2 is not requesting any other resources. It is not requesting any other resources. Okay, so it may happens that after few seconds T2 will complete its execution. Okay, and it will release the resource of R1, that is this instance. Okay, and once it releases this instance, this can be assigned to T1. Okay, because T1 is asking for one instance of resource type R1. So if T2 will release this instance, then we can assign this instance to T1. Then T1 will continue its execution, and once it finish, then it will release this one also, because we have started that request, then use and then release, right? So it will release the instance this one, and if it release the instance of R2, then this can be assigned to T3, and if T3 get the instance of resource type R2, then it can also complete its execution. Okay, so finally all the process will complete their execution. So in this graph also there is one cycle, but there is no deadlock. Okay, so these are two different resource allocation graph. Here if there is a cycle, then we are saying deadlock is there. Okay, and in this graph there is a cycle but there is no deadlock, right? And in this graph only single instances are there for each resource type. Okay, no, this is having multiple instances, but because of this assignment, T2 may release the instance of R1, right? And it is not requesting for anything else. So because of this assignment, there is a possibility of deadlock, but we cannot say there is 100% deadlock. Okay, so but in this case we can say there is 100% deadlock, but here we cannot say there is a deadlock. Okay, so some important points to be noted is that if the graph contains no cycles, okay, see, if there is a cycle, then there is deadlock. No, we cannot say like that. Okay, if the graph contains no cycles, then that means no deadlock. Okay, for a system to be in deadlock state, it should satisfy that circular weight condition, right? And circular weight is nothing but this cycle. Okay, there should be at least one cycle. Okay, but if there is no cycle, that means what? It is not satisfying that hold and wait or circular weight condition. Okay, so that means there is no deadlock. If the graph contains no cycles, then no deadlock. And if the graph contains a cycle, okay, then two different scenario will be there. If only one instances per resource type, then deadlock. Okay, if all the resources are having only one instance, then we can say there is deadlock. But if several instances per resource type, possibility of deadlock is there, but we cannot say. This is this case. Okay, see, there are several instances for each resource type R1 and R2. Okay, and since T2 may release this one, so we cannot say whether it will release or not. Okay, if it will release the resource this one, or T4 may also release this instances, so that we can assign this one to this T3. Okay, so if there are several instances per resource type, then there is a possibility of deadlock, but we cannot say there should be or there is any deadlock. Okay, so these are the two important points we have to remember. Okay, so we'll stop it here only. Thanks for watching, and if you have understood something out of this